Hello, today we're going to have a look at perpendicular and parallel gradients. So the first thing I'm going to do is I'm going to draw a line through 2 points, and then I'm going to add another point, and I'm going to put in a parallel line, so a line which is always parallel to this line but going through the point C. So you can see if I move my B point around, my lines stay parallel. Parallel means that they're never going to intersect, they're always the same distance apart. Now what I'm going to do is I'm going to have a look at what the gradient or the slope of my line is. So GeoGebra calls it the slope, I'm not quite sure why. So you can see currently the gradient of each line is 0.94. If I move my lines, the lines change, the gradients change, but because they're parallel, the gradients always stay the same. So they're staying at 0.77, 0.51, but crucially, the two gradients are always the same. Minus 2.19, always the same. So if two lines are parallel, they will always have the same gradient. Here we have a GeoGebra file I set up before, and this time the lines are always perpendicular. So that means that they are always at right angles. And you can see now that the gradients aren't the same, but there is a connection between them. And that is, if I do the gradient of the red line multiplied by the gradient of the blue line, I get -1. Just to prove to you that this is worked out, I've not just entered -1, it's doing the gradient m, which is this gradient here, times by the gradient m1, which is this gradient down here, and it is finding that it is always -1. Doesn't matter where they are, I can move the lines, they don't have to stay in the same place, it doesn't matter which lines I do, the gradients will always multiply together to give me -1. So if two lines are parallel, they have the same gradient. If two lines are perpendicular, then their gradients multiply together to give -1. Another way to think about that is, say I had a gradient of 2, what gradient would I need to multiply that by to get -1? Well, I would have to multiply that by -1/2. If I had a gradient of 3/4, then I would have to multiply that by a gradient of -4/3. So what we're doing is we're multiplying by the negative reciprocal. So in common speak, that means flip the fraction or do 1 over it if it's an integer, and then change the sign. So if it was positive, it becomes negative. If it was negative, it becomes positive. Let's have a look at how this crops up in exam questions. So here's a question from the OCR Core 1 paper from June 11. The points A, B and C are joined to form a triangle. So because this is going to be a slightly involved question, I'm going to draw my points. I know that 3 points must form a triangle. There's a point at 1, 3, there's a point at 7, 1, and there's a point at -3, -9. Again, when I'm drawing a picture, it doesn't have to be accurate. I'm not after a photorealistic picture. I'm just after something which I can use so that I can put down any thoughts, any information. It might just help me see what's going on a little bit better. So we've got our points, and we're asked to show that this triangle is a right-angled triangle. Well, we already know it's a triangle. It's told us that it's a triangle. So I don't have to justify it being a triangle. All I need to do is find where the right angle is. That is that the lines are perpendicular. To do that, we need the gradient. So that's telling us it's a gradient question. There are 3 ways of finding the gradient. You will be sick of me telling you this. The first one is to rearrange the equation of a line into the form y equals mx plus c, and then see what the gradient is. Well, we don't have the equation of a straight line, so I can't do that. The second method is to use coordinates and to find the gradient between 2 coordinates. Well, I've got plenty of coordinates to do that with, so that's looking good. The third method is to use calculus and differentiate, and if you've got a curvy line, that will tell you what gradient is. But we don't have a curvy line, we've got straight lines, so we're going to use the second method. We're going to find the gradient using 2 coordinates. So I'm just going to do this quite quickly. The change in y, well, if I start at -9 and I go up to 3, I've gone up 12. Divided by the change in x, well, I've started at -3, I've gone up to 1, so I've gone up 4. So the gradient of this line is 3. In the exam, I would expect you to show more working, so to state that you're doing the change in y over the change in x, you might want to put m to show that you're finding the gradient. Here, I'm starting at 3 and I'm going down to 1. So that is -2, I'm going down 2. And I'm at 1 and I'm going to 7, so I'm going across +6. So this is -1/3. And then my final gradient, I'm starting at -9 and I'm going up to 1, so I'm going up 10. And then my other one, I'm starting at -3, I'm going across to 7, so I'm going across 10. So this is a gradient of 1. So if you remember, we want to show that we've got a right angle. Well, the right angle is where the gradients multiply together to give me -1. Well, I know that 3 times -1/3 gives me my -1. So because of this, I know that the edges AC and AB are perpendicular. The reason I know that is the gradient of AC times the gradient of AB gave me -1. And then we need to state whether the right angle is at A, B or C. Well, hopefully you can now see that the right angle is here, so we can now say that the right angle is at A. Now it happens to be that my picture made it look like the right angle was at A. I honestly didn't know that that's where the right angle was going to be. I wouldn't have worried if I found that my right angle was down here at B. That would be fine. Your picture doesn't have to be accurate. Okay, so that's one case where we've had to find the perpendicular gradient. Let's have a look at another question. So this time we're doing the January 11 paper. The points A and B have coordinates 6, 1 and -2, 7. Find the gradient of the line AB. So again, we're starting at 6, 1. We're going to -2, 7. My gradient is equal to my change in y over my change in x. If you want to show this quicker and you don't want to write change in, you can just write delta. I tend to write change in just because it helps me remember what's going on. So my change in y, well, I started at 1, I've gone up to 7, so I've gone up 6. And then my change in x, well, I started at 6, I've ended up at -2, so I've gone backwards 8. So this gradient is equal to -3/4. Determine whether the line 4x minus 3y minus 10 equals 0 is perpendicular to AB. So again, we're looking at perpendicular. So that's a key word to make us think gradient. There are 3 ways that we can find our gradient. We could do rearranging the equation of a line into the form y equals mx plus c, using change in y over change in x, or differentiation. Well, here I've got the equation of a line which I can rearrange. So I'm going to start off with my 4x minus 3y minus 10 equals 0. I'm going to rearrange that into form y equals mx plus c. So I'm going to say 3y equals 4x minus 10 and y equals 4/3 x minus 10 over 3. So the question is, are these perpendicular? Well, we know that 2 lines are perpendicular if when I multiply the gradients and I get -1. Well, the gradient of the line section is -3/4. The gradient of this line is 4/3. So I'm going to multiply them together. I'm going to get 4/3 multiplied by -3/4. And I get -1. Therefore, I can say that these are perpendicular. Okay, so the key points from this video is that parallel lines have the same gradient and the gradient of perpendicular lines multiply together to make -1. I hope that's been useful and you'll carry on making use of these YouTube videos.